This is Pre-Calc 12, Chapter 1.4. We're going to cover relating polynomial functions and equations. First of all, we're going to learn a definition, the degree of a polynomial. This is the term with the highest power. It's the sum of all the variable exponents. For example, this one's easy, x to the power 5, so that's degree 5. X squared, y squared, we sum the exponents, so that's 2 plus 2, so this degree is 4. Here we have two terms. We have x squared y cubed, so the degree here is 5. Here we have 2 to the 6th, y to the 4th. The degree here is 4 because we don't take the exponent for constants. We only take exponents for variables. So the degree here again is 5. Leading coefficient. The leading coefficient is defined as the coefficient of the term with the highest power. So we have a degree 4 here, degree 3 here. So this one's the term with the highest power, and the leading coefficient is -3. Here we have degree 4, here we have degree 3, so we just use the leading coefficient here, which is +4. We classify polynomials as even degree and odd degree. So from the last lesson, where do the even degree polynomials finish? And we have two cases. When they start in quadrant 2, they finish in quadrant 1. And we also have a global min here. So this is quadrant 1. When it starts in quadrant 3, where does it finish? Quadrant 3. It finishes in quadrant 4. Okay, and we have some mins and max. This is a global max. Here we have a local min. And here we have a local max. And for odd degree polynomials, determine where they finish when they start in quadrant 2. So this one starts in quadrant 2, it ends up in quadrant 4. Here we have some min and max. This one is a local min. This one is a local max. Okay, it's local because up here it's bigger than here, so this is not an absolute max. And again here it's local because this part is lower, so it's not absolute. Okay, so when they start in quadrant 3, they finish in quadrant 1. And again we have local mins and max. We have two local mins. And we have two local max. Okay, the next thing we have to look at is polynomials generally have peaks and valleys. So we've seen that. This means they can have global or local mins and maxes. And the definition for the lowest point is the global minimum and the highest point is the global maximum. And recall that for even degree, we have globals. For odd degree, we don't have any globals. So here we have 3 peaks and valleys, and we have a global min. And we have local mins and max. Min, max. And they're both local. And here we have 3. And there's our global max. And we have a min and a max. And they're both local. And a global max can also be referred to as absolute. The maximum number of min and max is 1 less than the degree of the polynomial. Here's a question. Can an odd degree polynomial have a global min and max? And we looked at that and the answer is no. Multiplicity. Okay, the multiplicity is the number of times 0 or root repeats. And we say zeros for functions, we say roots for equations. It's a small distinction, but it's important to try to use the right terminology. And we classify multiplicity as odd or even. Here we have even. Here we have odd, because 1 is implied. Okay, and here, again, we have even. And here, it's definitely odd, because it's not implied. Even multiplicity will have the curve touch but not cross the x-axis. The other way to say this is it will bounce off the x-axis. Odd multiplicity will always have the curve cross the x-axis. Okay, we use these properties and definitions to help us graph. Here's an example. Y is equal to negative x plus 3 squared times x plus 1 times x minus 2. The y-intercept here is 3 squared minus 3 squared times 1 times negative 2. And this gives us a y-intercept of 18. And if you're not sure of brackets, the precedence is to have that. So we have 2 negative signs, the answer is positive. Okay, so how do we decode this? This implies the concavity is down. And this is even. So it touches. And for these two, we have odd. So it means it crosses. Okay, so how do we draw this? This is not to scale because the x-axis goes by units of 1. We're going to have to go by units of 3 here for the vertical axis. So 3, 6, 9, 12, 15, 18. Before we graph, let's just cover some graphing tips. We use the intercepts, so we have 4 intercepts. There are smaller peaks and valleys when the zeros are closer together. The polynomials are smooth and no jagged edges. And you always factor before sketching. Fortunately, this one is factored for us. We look at the zeros. These two are closer than this one. So this one will have a bigger peak than the valley here. And what else do we know? This is a degree 4 polynomial and it's concave down. So it means we need to start below. And at negative 3, it touches, it bounces. We go down and back up. And at negative 1, it crosses. Now, is the peak going to be on the left or the right? Well, it's going to be halfway between these two, so it's going to be on the right. And there we go. We've drawn it so that this valley is smaller than this peak because they're closer together. And that completes this graph. And our concavity is down, which matches what our graphing rules are. So let's look at odd and even. We use odd and even in many different ways. So let's just review it. We have odd and even numbers. You know what that means? We have odd and even degree polynomials. So those have certain meanings. We have odd and even multiplicity. So that has meaning. And you need to review all these. We have odd and even functions. We haven't covered this yet. We will be covering this later, but there are lots of different ways to use odd and even, so you need to be clear about how you are specifying it. So you need to say odd or even numbers, odd or even degree, odd or even multiplicity, and odd or even functions. And that completes this lesson.